Okay, today we're going to be learning how to solve equations of same base exponentials. An exponential is in the form y equals b to the x, where b is the base, and b can be a value must be a value that is greater than 0, but cannot equal 1. So it's going to be a positive value from greater than 0, and it cannot equal 1. The x is the exponent in the problem, but the exponent can equal any real number. So while the base must be a positive value and cannot equal 1, the exponent can be any real number. Okay, so let's look at the exponential equation. 2 to the x power is equal to 8. Now, in order to solve this problem, we must get the bases to be the same value. And you should know by now that 8 can be represented by 2 to the third. This will give us 2 to the x is equal to 2 to the third. Because the bases are the same, then their exponents will be equal. So we can cancel out the 2's and simply get x is equal to 3. Okay, so we're going to look at another problem. We have 3 to the x plus 1 is equal to 27. Again, we must get our bases to be the same. And so we have 3 to the x plus 1 equals, and then we're going to change 27 to 3 to the third. The bases now cancel out, giving us x plus 1 is equal to 3. And then we subtract 1 from each side, and we get x is equal to 2. Okay, here's a bit more complicated example. 16 to the 2x is equal to 64 to the x plus 3. Now, neither of these bases are the same, so we have to get a common base. And what we're going to be normally looking for is a prime number, such as 2, 3, or 5. Although they can have larger bases for the purposes of the Algebra 2 class, we're going to be looking at a value that is a prime number less than 10. So, we know that 16 can be represented as 2 to the 4th. And then we put that to the 2x power. And 64 is represented by 2 to the 6. And that is to the x plus 3 power. We multiply our exponents together, giving us 2 to the 8x is equal to 2 to the 6x plus 18. Our bases cancel, giving us 8x is equal to 6x plus 18, and then we subtract 6x from each side, giving us 2x is equal to 18, and therefore x is equal to 9. Okay, here's a bit more complicated example. Notice we have on the right-hand side 1 over 27. Now remember, we can get a positive base here simply by putting 3 to a value that would give us 1 over 27. So let's start with the left-hand side, and we would take 81, and we would have 3 to the 4th power, which would give us the 81, and then we're going to have an exponent of x plus 5. That's going to be equal to, now again, 1 over 27. We know 27 is 3 to the 3rd. But since we want that value in the denominator, it would end up being 3 to the negative 3. And then we take that to the power of 2x. We will then multiply our exponents together, giving us 3 to the 4x plus 20 is equal to 3 to the negative 6x. Our bases will cancel out, giving us 4x plus 20 equals negative 6x. Bringing our positive 4x over to the other side gives us 20 equals negative 10x. And therefore, dividing by negative 10, x would equal to negative 2. So I've given you a number of examples here, and hopefully you'll be able to do the problems on the worksheet. If you have any questions, please be sure to ask me in class tomorrow. See you then.